Welcome to A1 Digital. This webinar should be interesting for any company that is developing or using IoT solutions. And our audience is very international today. We have compiled a lot of useful information for you, and we hope that you leave this event with great benefits at the end. Your speakers today are Liliana Marjanovic, Product Manager for Managed Connectivity, and Peter Gaspar, Solution Architect. And I'm Philip Koenig, Product Marketing Manager for IoT. And we all work at A1 Digital, but in different countries. And now, without further ado, I'll hand over to Peter.
I will go quickly through the agenda that awaits us today. We will start with a short introduction to A1 Digital, so that you know who we are and why are we talking about the 5G. Then we will go through some common use cases that are now in the market of the IoT, and we will elaborate a bit how to choose the right technology for that. Further, we will look at how the 5G is addressing these requirements in the market and what are the technologies that the 5G can provide today and in the future. I will then do a little introduction, a technical introduction into the low power wide area network, so technologies that enable IoT use cases with a low energy consumption and how they fit into the 5G architecture. And at the end, we will summarize and show you a few references from our Austrian, German, and international market. Good. Very quickly about who we are, A1 Digital. We are a member of the A1 group. We are a product house for digitalization for the whole group and all the companies within the A1 group. We were established in 2017, so since 5 years, we really focus on IoT, digitalization, cloud services, and security. We have more than 1,500 customers around the world, actually, with about 200 employees. Our locations are in Munich, Vienna, and Lausanne, where we also have the data centers, plus some data centers in Frankfurt, where from which we serve our cloud services and also where our internal systems are running and positioned. In our portfolio, we have basically we cover the full chain of the digitalization from the IoT devices and hardware and the data collection through the connectivity of these different digital devices to the platforms in the middle, and then getting the data out from the platform for the machine learning services and platforms, as well as towards the asset management and the asset analytics platforms and products. So we basically cover the full chain of digitalization, but today we will focus on the bubble here on the left, on the connectivity for the IoT businesses. This is a very short introduction into the A1 Digital, so we do not waste too much time on that. And I will now hand over to Liliana to show you a few use cases and how these use cases can be mapped to the right technology.
Welcome to our presentation. Thank you, Phil, for the nice introduction. Now we are coming to the part where we need to basically decide on the right radio technology. The thing is that each IoT use case is unique, basically, and there is no one-size-fits-all radio technology. So we really need to be careful if we are, for example, developing our own IoT business or want to use the IoT solutions. We need to know like which kind of requirements our application impose, and then map specific applications to the specific use cases to the corresponding radio technology. These slides aims to compare two different IoT segments. On the left-hand side, we have a massive IoT that supports low power devices, low cost devices, And on the right-hand side, we have a broadband IoT, basically. Unlike broadband IoT that needs a larger bandwidth and a low latency, massive IoT is focusing more on energy efficiency and penetration. But let's look back what we had and where we can position ourselves nowadays. So basically, M2M or machine-to-machine communications have been here for decades, but over the last decade, it turned into something that we call Internet of Things. And it can operate over cellular 2G, 3G, 4G, etc., but also it can operate at unlicensed frequencies. So there are a few different IoT segments. Basically, we today are focusing on a massive machine type of communications or massive IoT. And for such a kind of IoT, basically we have attendant network, low power wide area networks that can operate at licensed spectrum and also at unlicensed frequencies. So within a licensed spectrum, we have two famous technologies, LTM and narrowband IoT, whereas on the other side, we have Sigfox, LoRaWAN, and many others. What is important to mention here and what is important to highlight is basically that stepping into the 5G era, many regulators and service providers are sunsetting 2G and 3G. They want basically to reuse valuable spectrum for upcoming technologies. And of course, IoT will benefit from the expansion of LTE and 5G because they open up new functionalities. It is also worth mentioning that if we are people who are developing our IoT business, we should be sure that we have compatible devices with upcoming technologies. So we need to ensure that we have future-proof IoT components. Why IoT over cellular? So there are a few things that I would like to list here. First of all is extensive coverage that we get using a network agnostic SIM cards that can attach to the different carriers. Then we also have a possibility to roam between the different networks. It can be integrated into any device. There is no network setup necessary. Cost for tariffs and modules go down. And there is, of course, high security that can be ensured additionally by a VPN connection, for example. Can it be different? Of course, as I mentioned at the beginning, we can also operate in unlicensed spectrum. So, and what we have actually here. If we are talking about LPWAN, there are two different possibilities to operate in license and unlicensed. And some of the common features are basically low power, low cost, low data rate features. But let me just point out here what are the benefits of both sides. So basically for the license spectrum, it's more or less clear, right? We have a higher reliability. We have also good or high security and redundancy. On the other side, for the first, what comes to my mind is basically the pricing. So unlicensed spectrum or the technologies within that are less costly. There is a very big problem of interference where two devices, for example, want to use the same portion of the spectrum and they are attaching to the different networks. Yeah, that's the really problem that we are facing here. The other advantage of using unlicensed spectrum is basically increased utility of the devices. So if you really need a device to measure something, to get some meaningful information, then it's better to use that than have a zero, right? And the third feature that I would point out here is independency, because we are also able to deploy private network and not caring about external operator, not paying additional fees, etc. We are coming to the new mobile communication standard, basically, and the 5G technology. And 5G basically is supporting diverse requirements. On one side, there are human-centric requirements. On the other side, there are machine-centric requirements. And 3GPP identified 3 use case families. First, we have enhanced mobile broadband that requires higher bandwidth and higher data rate. And some applications that are supported by this use case family is basically, for example, video streaming. The second one is ultra reliable low latency communication family that requires low latency with a high reliability. And some applications are, for example, autonomous driving. The third one that we are focusing on is based on massive machine type communications that supports the family which supports low data rate, low power, low cost devices. And there are a few standards basically that can cater to these applications. So for enhanced mobile broadband, it is a 5G new radio. For ultra reliable low latency communication, it is private 5G networks. And within massive machine type communications, there are 2 technologies that I already mentioned, narrowband IoT and LTM. They were initially designed for 5G, but they rolled out forward to work in 4G. We need just a smart way to embrace it within a 5G. Another classification is based on a maturity level. So this plethora of applications have not a root equally, or they don't have the same maturity level. So massive machine type communications family has the basically high maturity level. Unlike the other 2 families, ultra reliable low latency and enhanced mobile broadband, have applications at a very low or a medium maturity level. So they are not in wide use.
Thank you, Liliana. So I will continue with the introduction into these 2 technologies, the narrowband IoT and the LTEM. But I just want to reiterate what probably the most important message of this webinar is: the 5G is not replacing these technologies. Yeah, the 5G is embracing these 2 technologies and is integrating them into the end-to-end architecture of the 5G. So if you decide to build your solution on top of the LTEM or narrowband IoT, your future is basically secured. What are these new technologies, or let's say not that new, but the first deployment started in 2017, 18. These 2 technologies are now available on the market. And what do they provide, or what is the goal of these 2 technologies? Is to provide a low bandwidth, but a very energy efficient communication for the usually battery powered devices. That's where their strength is. So what are the expectations on these 2 technologies? So battery life, as I mentioned, needs to be long, or even, so to say, very long. So with the narrowband IoT, the specific use cases that can achieve more than 10 years lifetime in the field with the batteries of 5 watt hours, or relatively small batteries, so that they fit into the devices like a water meter. Similarly, the LTEM aims at a similar time, but given the use cases that the LTEM is made for, these times will probably be somewhere between 3 and 5 years, usually, because the use cases will be more dynamic. Another quality of these 2 technologies is a better coverage. So they can penetrate the building walls or difficult radio conditions better. They can perform better in the difficult radio conditions, and therefore can be used for use cases that require a deep indoor coverage. So elevators, for example, or smart meters within the buildings. The data rates are, as I said, well, moderate. For the narrowband IoT, the theoretical value is about 200 kilobits per second, although most likely you would see something around 20 kilobits per second. So something for a really small amount of data, sent well, regularly, but not too often. LTEM is more like the Edge 2G equivalent. talking about the one megabit per second. And the consequence of this is also the support of the services that you see here at the almost at the bottom. The LTE-M is the technology that will also or supports also voice communication, whereby the narrowband IoT, due to its characteristics, is not suitable for voice communication. One of the characteristics that is making it unsuitable for voice is the latency, where the narrowband IoT, because it has a very efficient way of communication and is also designed for a high density of devices under one cell, it can happen that the device has to wait for quite some time to get the resources on the radio interface. So the latencies can be up to 10 seconds, whereby the LTE-M is almost real time. Therefore, also suitable for the voice, as I meant. Another characteristic that is making the narrowband IoT not suitable for the voice is the mobility. So the narrowband IoT devices, they can be mobile, but they can not hand over from one cell to another in a data session. So if you would have a voice call, or if you have a data session, the data session gets interrupted when you change the cells, whereby the LTE-M provides a full mobility like we are used to from LTE or 3G or 2G networks. And equivalent to these characteristics, also the cost, expected cost of the module, of the hardware communication module, is for narrowband IoT only about 5 euros per module, and for the LTE-M we're talking about somewhere sub 10 euros for a module. Here I want to illustrate that with the narrowband and LTE-M, we basically take over to the 5G world all the important features that are designed for the massive type communication and for the power efficient communication. The most important of these features for the energy efficiency are the power saving mode, the extended DRX, and the release assistance indicator. And you can see that these two technologies, when we take them over to the 5G, will cover all the crucial technologies that are required for efficient battery use. I will now go a bit more into the detail of these three power saving technologies, just to probably repeat what you have already heard, but it's good to refresh that. So if we talk about the power saving mode, what we try to achieve is for the use cases and the devices that only send irregularly a small amount of data, to enable them to go into the sleep mode. But after they wake up, we want to enable them a very efficient registration into the network again, so they don't need to go through the whole process of authentication and negotiation of the properties and so on. So the power saving mode enables the device to inform the network that it will be in a sleep mode for an extended period of time, so much longer than the normal LTE devices are. And still the network will keep the authentication information and the session information stored. So when the device wakes up again after a very long time, which can be, you can see here, it can be up to 413 days, the network will recognize the device and will allow it to transfer the data immediately without need for attach and other procedures to build up the session. So this is the power saving mode. So you can see when the device is in the sleep mode here, we cannot reach the device. It really is off. Yeah. So it's also not reachable from outside. If you have a use case or a solution where you need to reach the device itself from the outside because there is a user interaction, for example, required, like a smart lock or a bike sharing application that needs to unlock the bike, then you would go for the eDRX function. The eDRX does not put the device into the long sleep, but it reduces the times when the device is on reception. So when the reception is turned on, because you may want to, if you say that you need to be to receive the information from the network every 10 seconds, which might be enough for example, the bike sharing, because the user will be willing to wait for 10 seconds, or you can keep him busy for 10 seconds before you unlock the bike. You can save a lot of energy because you can switch off the receiver. Yeah, you can see it here when the receiver is off for quite a good share of the time, and therefore save a lot of energy, a lot of battery by only listening at the predefined periods. You can also here see the timers. There are 2 timers for the DRX. It is how often, so the cycle, how often you listen, and for how long. This is the paging time window. And you can see that the paging time window, or the period when you listen, is somewhere between 1 and 20 seconds on LTE-M and 2 and 40 seconds on the narrowband. And the cycle can be up to 10,000 seconds. Yeah. So a typical use case would be that you have a 10-second cycle, and only 2 seconds listen. So you can basically save 3/4 of the energy by turning off the receiver. And then you can combine everything. You can combine the power saving mode and eDRX that you would do if you have a use case that initiates the connection, and then for some certain period of time, it waits for the response from the network. If it doesn't come, then it goes into a deep sleep. Yeah, so this is a combination that during the period when you are still woke up, you still reduce the receiver power by switching it off in the meanwhile at the periods, and after you see that no data has come, or the power saving mode activity time has expired, you can go into the deep sleep. So you basically use both technologies in combination. It's not so common to use that because the use cases usually are either more focused on the eDRX or more on the PSM. But one thing that is here, and it's not so prominent, is this RAI. And this is a very important feature for the power saving, because in a normal case, when you have a data transmission, like here at the beginning, after the data transmission, the device and so the network keeps the device in the connected mode, RRC connected mode, which is a very power demanding mode where the device is basically all the time on the receive and is monitoring the paging channels and consumes a lot of energy by doing nothing. Disconnected time can take somewhere between 3 and 20 seconds, depends on the network configuration. For example, in the A1 network, this is only 3 seconds, but I have seen networks where it's 10 seconds and 20 seconds. And the RAI is a function for the device to inform the network that it has no more data to send, nor is it expecting any data to come back immediately. So it informs the network, you can basically disconnect me from the connected mode immediately. And therefore, this 3 to 10 seconds to 20 seconds of a very high consumption of the power can be reduced to 0. So this is the third power saving feature that can be used in the narrowband IoT and LTE-M, which can contribute to this longer, extremely long battery life. As I said, the use cases usually are focused more on or go into the direction of power saving mode or eDRX. Here is a little guidance on how to decide which of these to use. If your use case or if your solution needs to communicate very, very rarely, so every 2 weeks, like a smoke detector, hopefully never, then it's probably more efficient to completely turn down the communication module. So you basically turn it off, and you turn it on whenever you need to communicate. If your solution needs to communicate more often than every 48 hours, for example, so if it's a water meter or a weather station that reports every 24 hours, it's more efficient to go into the deep sleep mode than starting the whole module new, right? So there, in that case, you would go into the power saving mode, sleep for 24 hours, wake up, transfer the data. it's more efficient than stopping and starting the whole module. The eDRX again is for the use cases where you need to reach the device, and you can see here the share bike, robot mower, and different other use cases. What happens in the with the LTE-M and Narrowband IoT in the 5G? So we know that we have these deployments today. You probably, if you are planning a new solution, you are thinking about the Narrowband IoT and LTE-M. And again, the most important message of this webinar is the 5G retains and includes these both technologies into the end-to-end architecture as a native protocols of the 5G. So the enhancements for the 5G are the coexistence within the one spectrum with the new radio of the 5G and the integration into the 5G core network. So the whole, both of these technologies are then natively part of the 5G. And we have a few power optimizations prepared for the future as well, using the data transfer before the connection is built up. So in some shared channels and some signaling channels, a small amount of data can be sent. And then a specific DRX, this is the small timer between paging occasions in a normal receiving state, which also can be then optimized to the use case. So again, most important, 5G will keep the two technologies evolving. How these are used in the world, you can see the map here, and you can go to the GSMA website to see how these two technologies are deployed around the world. If you are planning a solution that should be available worldwide or Europe-wide, you can check here which countries are betting on which technology and decide on the best combination for you. But just to give you an example how it is in the countries, in Austria, we have a coverage that is virtually equivalent with the LTE coverage. Both of these technologies are software enhancements on the base stations that we have. So if we enable them, or when we have enabled the Narrowband IoT, the coverage was immediately countrywide and even a little bit better than the LTE coverage we have because of this 20 dB gain of the technology. If you want to start working on your own solution, or if you want to test the solution that you have purchased from some vendor, you're welcome to contact us, and we can provide you with the lab, IoT lab facilities that we have in Vienna. You can do prototyping of your future solution. You can do troubleshooting of the hardware, for example, that you have already built or that you want to evaluate. You can look at your ready-made or developed products and test them in different radio conditions. So and measure their battery life under stress conditions or under load conditions. That's something also we can provide you in our lab, or we can jointly try to innovate and look at the very new cutting edge features of these two technologies and try them out in the laboratory environment. So this was the technical part from my side, and I'll give it back to Liliana for showing you a few references.
So I wouldn't go into detail explaining one by one, but I would rather say what we do in common for all of them. So we offer IoT connectivity management platform. On top of that, also analytics model and business insight, then customized application for each of the customers, and roaming tariffs for worldwide network coverage. And yeah, to wrap it up, basically, I quote Abraham Lincoln, who says that the best way to predict the future is to create it. So while I was researching basically about potential directions of IoT in the future for beyond 5G and even 6G, I came across a lot of papers that share the same opinion. So there are a few things that can be improved for the future ecosystem. One of them is enhanced security and privacy. Then, of course, data analysis and management, sensing and monitoring, energy harvesting in order to eliminate all of these power cords and the battery charger. And the last is social IoT for connecting or making new networks for the intelligent and smart communications between devices. Regardless whether a standard will be in place for beyond 5G and 6G, these are the things that can be improved. Now back to you, Philip.
Thank you, Liliana, and also thank you, Peter. I have put the contact details of Liliana and Peter here, and you will also find the hyperlinks to the LinkedIn profiles of Liliana and Peter in the chat window. And if you find this webinar interesting and you need further assistance on this topic or other topics related to IoT, please consider our free consultation. You can request it on our website. I will put the link in the chat window for you. So please feel free to visit our website. And now I would like to go to the Q&A session because we have received several questions. So I think let's start with this one. For which technology should I go if my connected device is crossing borders?
Yeah, so as I have shown the map of the world, it's quite diverse. Yeah, so depending on the use case, if you can afford to also use the narrowband IoT, so if your use case is let's say uses a low data consumption and you don't need a voice, but you also want to have as much coverage as possible. In today's situation, I would definitely recommend a combined module. It means a communication module that supports LTE-M and narrowband IoT. Because with that combination, you basically are safe in the countries that have at least one of these technologies covered. However, you've seen that some of the continents are quite blank when it comes to the coverage. So for these, there is still the option to use the 2G. And I have had quite a few customers who have decided to use a combined module even with the 2Gs for the fallback. So primarily they try to use the LTE-M, then the narrowband IoT. And if none of this works, they fall back on the module to the 2G. The prices for the modules, for the combined modules, are not extremely different, yeah, from the LTE-M only modules, for example. So as I was talking about the 10 euros for the LTE-M module, the combined modules can be found for 15 euros, for example. So, and with that, you are safe worldwide today. If you are going to launch your solution in 3 years because you need some development time and then the ramp up, then maybe 2G will not be that much necessary anymore. And you may then also focus on the use case requirements and may decide only for one of these technologies. We expect that within 3 years, the coverage of both of these technologies will be much better than today, and you will basically be able to use any of those technologies worldwide.
Okay, thank you, Peter. I guess the next question goes to me. Surprisingly interesting overview, thank you. Will you share slides or recording? Yes, you will get an email in the next days and it will contain a link to the video recording. And we have one more question. I guess, Peter, this one goes to you. How did you calculate the 10-year battery lifetime?
Yeah, so the 10-year battery lifetime is something that has been calculated by the 3GPP already, so the standardization body when they were designing the protocol itself. But if you look at that theoretical calculation, there are even numbers of 30 years and more achievable, because they don't take into the consideration the self-discharging of the batteries and so on. But what we have seen in the field, where we have some experience over multiple years, where we see the devices being used, we can tell that with the 5 watt-hours of a battery capacity, and with two transmissions per day, we can reach the 10 years. Yeah, so that's about. The transmission means really low data, so we're talking about the 20 bytes of data per transmission. We can comfortably reach the 10 years.
Perfect. Thank you very much. That was our last question. So no more questions. We have reached the end. Again, thank you very much to the speakers and also to the audience. And see you next time. Have a nice day.
Thank you very much.
You.